Now we'll look at A/B testing. First, load the delay data for the United Airlines. And then display the first 3 rows. Okay, we see the date and the delay, and those are going to be important for us. We're going to want to add a column to this table that contains the month of the flight number, for example, 6 for June. So let's write a function that takes a string called dateString and grabs its first character. That's the way, the initial character. And then let's call that inputs its first character. Call the table United as well. So we're going to take this. United is now going to be United, but we're going to add a column. And that column is going to be called, I don't know, month. And it's going to consist of an array of values. And what values? We're going to take United and apply the month function to the date column. And that's the United table. Let's have a quick look at United with, say, 3 lines. And there's the month as expected. Okay, so how many entries are there for June? How many for August? This is fairly straightforward because for June, you can just filter this United table. We check where the month is equal to 6. It's the string 6. And we could calculate the number of rows. And similarly, we can do something like that for August, the 8th month. And we could give these things names like June, num, and augnum. And then we could display the pair of them. 4508 for the June flights and 4632 for the August flights. We're going to focus on those flights, so we're going to make a table that only contains flights in those months, and we'll call that new table ends. How many rows does this new table have? Well, okay, so it's going to have rows equal to the sum of these two numbers, but let's make the table. Ends is going to be equal to United, but we're going to filter out some rows, so where month are not equal to 7. And then we're interested in knowing the number of rows. There's 9140 rows, and that's the sum of these two numbers. So we're looking pretty good. Make a histogram of the delays grouped by month so that we show 2 distributions on the same chart, one for June and one for August. We should have certain bins. Okay, so we want to take the ends table. We want to make a histogram. And we want the delay column, and the bins are going to be starting at 0, ending just after 200, separated by 10 each time, and then we want to use the group command to group by month so that there will be 2 histograms here, one in dark blue for June and the other in gold for August. And they look to have similar patterns, but we do see a bit of a difference in the number of flights in August that are flying pretty close to on time and lower numbers of delays. So that seems sensible. Write a function diff and delays that takes as input a table with columns including month and delay and returns the difference in mean delays for the June and August flights. Okay, so our table now is called TBL. It's the input table. And we're going to take TBL and we're going to look at one of the, well, first we'll filter where months are equal to, let's say we take the June dates, and then we'll take the column that consists of the delays, and now we've got an array of the delays in June, and we want to take the mean of that. So this is the mean of the June delays. I can copy this over here and take the mean of the August delays, and I want the difference to be returned. It's a pretty long calculation. Let's apply the function to our table, to our ends table. Sorry, we've got an error here. Delays is not in the table. The row is called delay, not delays. There we go. Now we'll write a function shuffle and get diff that takes no input values. It should first create a new table containing all the data from ends, but with the months column permuted. Okay, so we're going to call this shuffled, our new table, and we're going to take ends. And what do we want to do? We want to permute the months. So let's call this the following thing. So we'll take ends, we'll sample that table, and we'll sample with replacement equals false. And this will give us the same table as ends, but just with the rows all shuffled around. And now I want to take the month column from this table. And so let's call that shuffled months. And okay, so that's an array of the months in ends, so June's and August's that have been shuffled around. And what we're going to do is we're going to make a new table, and it's going to be like ends, but I'm going to drop the month column, and then I'm going to add a new column, and it's going to be also have the label month, and it's going to have as its values the shuffled months. And then we'll return this new table. I'm sorry, we don't want to return just this new table. We'll return our function diff and delays called on this new table, so that we get a mean value of the difference in the means. And it's called shuffle and get diff. And there it is. That's a small negative number. Okay, compared to our much bigger number here when applied to our actual table, right, without shuffling. And now we're going to do this shuffling and getting the difference 500 times, and we'll store the results in an array. Let's call that array of 500. And to start, it has nothing in it. And then we'll do a for loop. And we'll get a statistic value. And that statistic value will be obtained by doing shuffle and get diff. And then that gives us a number. We're going to append that to our array of 500. Okay, now we can make a new table and add the column. Call this statistics maybe. And put our array of 500 statistics into this table. And let's give that table a name. I don't know, table of 500. and then we'll plot the histogram. And then we have to fix the error because I forgot my H in my shuffle. Looks kind of bell-shaped, and it goes pretty much between -2 and 2, maybe between -3 and 3. I don't know, -2.5 to 2.5. Certainly, if we had a statistic value between -2.5 and 2.5, we'd be pretty confident that it came from maybe from this distribution. If it was way outside those ranges, then we'd be pretty suspicious that it would come from this distribution. And that's what we need to do in question 19. We need to test the hypothesis that the 2 months have different distributions. And the null hypothesis is, as usual, that they have the same distribution, so that we can simulate using A/B testing. And in that situation, the month labels and the flights are just random, and any variation in the samples is just due to chance. And the alternative hypothesis is that the data come from different distributions. And we're going to use the absolute value of the difference in the means of the delays for the 2 months as our test statistic. So essentially the absolute value of these numbers here. And these numbers would then go between 0 and 2.5, let's say. But our test statistic is here, the observed value, and its absolute value is 7.5, which is quite a bit bigger than any of the numbers coming from here. So any number above 2.5 would make me pretty suspicious of whether this number came from this distribution, and so I would be pretty confident in rejecting the null hypothesis in those situations. So if the test statistic was above 2.5, I'd reject the null. And in our case, we clearly reject the null. We reject the null since 7.5 is much larger than 2.5, and this means that there is a difference in the distributions of delays for the 2 months. Thanks.